Okay, welcome everybody to Haystack Live. My name's Charlie Hull. I'm going to be your host today, and we've got a fantastic talk for you today. I've first let you know we are recording this session. We will be recording it and then putting it onto our YouTube channel quite soon. And we've got a talk for you today from Andreas Wagenmann. He's the data engineering manager and data science tech lead at Empathy, who are big players in the e-commerce search world. And previously, he's worked in academia, and he's also been at German e-commerce giant Otto. So he's going to be talking about Kolibri, which is very exciting. I've got a few more things to let you know about today. We've got another Haystack Live meetup coming up on the 12th of January. Evgenia from Toluca is going to be talking about data labeling for search relevance evaluation. So we're looking forward to that. You can sign up for that via the Haystack Live meetup group. Also, I have created a new map of search meetups. This is based on some old data I had from a few years ago. And if you go to searchmeetups.com, assuming that now redirects to the right place, otherwise look on the Open Source Connections website in the resources drop-down. There's now a clickable map of all the search meetups I could find around the world. And I've also got a health indicator, so you can see if they had a meetup recently or they haven't had a meetup for 5 years, in which case they may not exist anymore. But take a look at that. Any other meetups or events related to search, please do submit on that page, and hopefully it'll be a great shared resource for everyone. So the way today's going to work, I'm going to hand over to Andreas in a few minutes, and he'll give us his presentation. If you have a question for Andreas, please drop it into the Zoom chat. And then when he's finished speaking, I'll be asking those questions on your behalf. To try and keep it fair, I'll make sure that everyone gets a chance to ask a question in the time we have available. And I may ask you for clarification if I can't understand your question, or whether you've had a good answer, which I'm sure you will. So that's about it. Enjoy Haystack Live today. Haystack Live is brought to you by Open Source Connections, we're the search and relevance people. And with no further ado, I'm going to hand over to Andreas, our presenter today.
All right, Charlie, thanks for the introduction, and thanks for having me and letting me talk a bit about the project Kolibri. So first of all, let me share the screen. So today, actually, I hope you all are able to see the screen. Today, this will be a bit differently structured. So I often don't really like to prepare slides. This is a bit similar, but it's basically we will slide over kind of a storyline for today. So first, a few words. I kind of skipped the words about myself because Charlie gave a nice introduction already. So the first question is, okay, so what is Kolibri, right? And so first thing, it's this guy. No, it's probably rather those guys. So well, what is this nonsense? So okay, this should just symbolize that in the first part, you kind of have one central entity, while it's really what Kolibri is in the description here, and that is Kolibri is a general distributed processing framework with abstractions for data generation, transformation, and aggregation. And actually, Charlie mentioned that, like in the previous stint, I was at Otto and so on. And actually, the initial idea from creating this project was out of a discussion with René, who's also as Open Source Connections, who kind of dropped the word, hey, Akka might be nice for several things that you do in here. And at some point, I just decided to try it out. But we'll come to the actual stack of Kolibri a bit later. So what is actually the focus of the whole project? I just see my camera is blurring, but you still see the screen, so that's fine. So the focus points are, it should be lean. So I don't want to plug in like all kinds of queue databases or whatever. So that's basically to the right. Okay, you form a cluster and you have a bucket, right? You're good. So this is one point. On the other side, it should really serve as something where you can kind of define what the job is and let it execute efficiently, and so be flexible, like for several tasks at hand. Today, we will mainly address like, okay, typical use cases of offline evaluation and kind of exploration of your search result, keep and store of it. We will also walk a bit over visualization approach that came into the whole thing with today's release, actually. So that's another thing to party. So the first non-release candidate releases out. And another goal is, okay, make it scalable, right? So from a simple use case where you just need a few requests and then evaluate them to maybe at some point simulations, maybe as a central control center for performing load tests and so on. But again, like today's scope is more offline evaluation. All right. So at first I clarify a few questions about the project itself. So where can you run it? Okay, it comes already with readers, writers for AWS buckets. So it's 3 buckets, or for GCP. In general, you will find in the project itself, if you go to the GitHub page, you will also find Helm charts to run it like in Kubernetes. What it doesn't have is Azure reader or writer. So this is the only thing you would need to add. And you can start it up local. So the thing really is, okay, you can cluster the thing, but you can really choose how you do it. So if you can, for example, just pull up one instance and say you actually define the roles and the configuration that we will walk over later. So if it's compute and HTTP server at the same time, then it will do both things at once. In the usual setup, you will have one server taking the request what to do, and then the other one once executing. So the general stack for this project is written in Scala. And now the let's say, critical part is based on Akka. And I know it's there because sure, recent developments have not been nice. The license shift was not fortunate. So as per the project, different options, like for the future, there's a community fork. What won't happen is that there will be kind of a license adjustment, or if you're in a bigger company and this is used, which would come with the license change, that there's payment needed. So this will stay open source for whatever size, and respective action will be taken dependent on developments. And the front end is actually written in Vue 3. And we will also see more of this later. So as per the decision to write it that way, a few features that actually make Akka a nice fit for distributed processing. One is you get node discovery, right? So it's actually a configuration issue, a configuration change, whether you just pull off EC2 instances in AWS and you make the node discovery take its course. It's only via labeling, and they will find each other and form a cluster. Or in K8s, a similar thing there, just that it's a K8s specific discovery. So K8s stands for Kubernetes. And you can run it local and just define specific IPs, for example, configure who should find each other, and then cluster will be formed. You also have, and this is one thing that we see later in the mechanics. Kolibri is basically agnostic to what you ask. You just expect the JSON back. So whatever kind of configuration of your HTTP request you're sending, you expect a certain response. And so it also comes with back-pressured requesting on the target instance, which is nice. Then also with features to balance requests on multiple hosts. So we'll see later that in the configuration, you can basically define as many hosts as you want. If you can pull all of them up, then this kind of allows you to scale nearly linearly. That's nice. And the node workload balancing. So you can actually, we see later that there's a batching mechanism based on the overall job you define, and you can actually utilize routers of Akka to distribute it kind of evenly on the nodes who are then doing the job. And a further nice property is actually it removes the need for data structures to be thread safe. So you can use any data structure you want, because actors happen to consume messages one by one. And so those are nice properties. All right. But since we introduced kind of, okay, what the stack is and so on, we're kind of missing out a bit on the motivation, what is actually supposed to do, right? Okay, so one question would be, we look at search results, and so what kind of stuff interests us about it, right? So what is good to know about it? And one common thing to do is, okay, you calculate judgments. So for those not familiar with it, just judgments is basically giving you a numerical number, like how good a product fits to your query. Usually that's based on click logs to estimate, okay, if a product was more often bought for a specific query, usually there's also position where it was bought incorporated, and there are several approaches to do that. And then this is kind of condensed in the number, right? So you have information retrieval metrics such as precision, recall, NDCG, ERR, and the like. And this is kind of telling you, okay, you have a number. They are also giving you a bit more context in the sense you can define them for subsets of your result. And in this sense, you can extend the scope of what they tell you, right? But is this really like the only thing we could know? So first thing, maybe I do not have the data yet. Maybe I just have my index, right? Would still be nice to know what is where and be able to. This is what I kind of try to bring up here in the aspects. Although as first exercise, you can actually try to guess what those queries are meant to be. I think the first one was just kind of tech or electronic. I think it was electronic. So it's quite a mixture, but you can already classify kind of which ones would you find better suitable. And probably this signal of what is better suitable is already partially in the index that you in the index fields, right? So you could, even if you had no judgments, you could say, all right, maybe I have a category that is reflecting that. So if I knew where actually those products belonging to that category are around, so which would point at extending the concept of numerical condensed values to, for example, histograms on values and the like. And so metrics can really take any kind of shape. All right, I think the right one was actually fresh or no, in German frisch, yeah, so fresh. And it's all kinds of things, right? So you have underwear, you have a coffee machine, and a smoothie maker, and stuff to clean up. So that's interesting variety. All right. So regarding information retrieval metrics, yeah, nice, but they're certainly not giving the whole picture. Then you have the shape as well. So where are specific things? What is where? That is not so easily condensable into single numerics, which relates to the what. You could define metrics that reflect the context, right? We've seen in past talks at in Berlin, for example, that the context sometimes can actually boost up certain products. Let's say something. I think Andreas Wagenmann was it back then that who said that okay, sometimes even putting a bit more valuable product besides another one that you want to sell can already kind of boost this up as a kind of context effect, right? So while it just seems like a sequence, there's actually a lot kind of meaning in that, but right? Maybe you could think of a metric that actually reflects that, right? Maybe it's more complex than a floating point number, right? And all right. Another thing that might interest you, okay, how is actually the type of products that I have, how is it actually moving while I make changes? And yeah, this would also reflect from a bit more information, benefit from a bit more information. And another topic that's probably gaining more and more importance is actually the topic of validating of black box mechanisms. So for example, nowadays you have like the modern e-commerce shop has a lot of auctions in there, sometimes resorting and the like. And all these things make assumption about how they affect your search result. But wouldn't it be good to have a mechanism to actually check this out? Like, okay, the properties that this algorithm promises me is actually fulfilled. Often the case is that people start querying their web shop, and then see from, like, let's say it's anecdotal evidence. There's still a lot of value in that. You certainly need to do that. But it would also be nice being able to do this a bit more systematic. All right. Let's come quickly to an evaluation scheme, right? So this is probably most of you like are familiar with similar evaluations. So here, visualized to the right, would be a combination of nodes in a computing cluster. And they are, I didn't feel in the current situation to include an actual gun, so I opted for water. So actually shooting like requests on some other nodes, and receiving back some JSON format with the actual information of what your search result is, then doing something with it and storing the results in a bucket. Simple as that. So now we have the topic of, all right, I mean, how is the requesting done, right? Also something you're all familiar with. Request can look like that. So you can have like a URL here, like a context path, certain parameters, all might come with different possible values. So you might have 1,000 queries, 40 different types you want to test, maybe 100 combinations of remove categories with 50 combinations of boost categories. So like some you would just remove out the search result, some other ones you would boost up. So this is not any particular format. This is kind of made up, but just to say this very quickly sums up combinatorial, right? So with those few variants, you would then end up like with 200 million single queries. So, and the broader your web store is, the more different contexts you want to evaluate, certainly the more the number of requests you would need for that could explode. All right, so how is Kolibri actually making your life easier a bit? So the way Kolibri works is really down to earth, right? You tell them like, okay, there's a certain thing that I want to do with some job definition that we will clarify how this is structured and processed later on. But then it really provides you convenience functions to just compose all this, also this combinatorial effort that you see going into those values, combining them. And for example, if you want to execute a grid search, then this can be quite heavy. All right. So here you actually have representations for normal URL parameters. Kolibri provides means to pull them from different kind of things. You can enter values directly, pull them from files. So different things. The representations here would be URL parameters, headers, bodies. Bodies can contain placeholders so that you don't need to reflect this in the data that you permutate, right? So you can just need to permutate the placeholder, can keep the body constant and just use the values to replace in the body. And by this, just have this combinatorial advantage. And so also in different contexts are they appearing. So you can have standalone queries, which basically mean standalone parameters, which basically means all of them you just permutate fully against each other. But sometimes it makes sense to restrict the space a bit because, like, especially when you do grid searches, can be quite expensive. And so how about introducing mappings that provide you scope? So let's say certain parameters are just valid or a subset of categories you want to apply. Then how about the right approach? Like you define here, it's called yummy attribute, can take 3 values, sugar, fructose, and corn syrup, makes the stuff you buy nicer when it's food. In the end, the address is birdfood.com. And then you have map values, right? Which basically for every value that comes here in the key generator provides you like values for this parameter here, which is called map value 1. And then you might have another one that maps to this, and you might have a third value that actually maps to one of the map values, right? So you can actually, it's just convenience to combine things that way so that you really limit it to the subset that you need. And by that, possibly making it also much faster. All right, what you then need to specify actually in Kolibri, we'll see some example definitions later on. You still need to decide on key mapping assignments. So you need to say, yeah, the first, which is always index 0, the key generator here at the beginning, maps to the value 1 here, which is the next in sequence. Then also 0 is providing the keys. So the first one is providing the keys for the second value as well. But then the second is providing the keys for the third value. And again, just convenience. For the types, I switched the order here a bit. For the general types, you have, okay, these are standard URL parameters. So it would be boost equals 0, equals 1, and so on. Going over those. So queries could be shoe, jean, shirt, milk, bread, or whatever. Headers could be, okay, X my pref, could be salty or whatever. So these can really contain anything that makes a valid header. And then they would just be permutated like every other value. And then you have replace value. So here's actually not a restriction. You don't need to place any particular format here. It just needs to be that in your body that you define in your requests. Yeah, you define the body and the identifier is findable. So there's no specific format given, so the string would just be replaced with the at the point valid value for the permutation. I hope this is clear. Since you permutate over a lot of values, every permutation will carry one value of the replace value, and this will actually make this contain the value. And so I think most requesting schemes are covered. So if it's like itself, if your server expects itself a JSON format, then this is also covered, and you can modify all other parameters there. All right, I'm going a bit down because like I want to come a bit like to the okay, what does it make simpler, right? Okay, to the left is actually a response as said, like we expect JSON format, and the left represents that. And then these are actually selectors as used by Kolibri, right? So plain selectors are just in this format. Then you can have recursive selectors like in docs contain actually an array of documents. And since this is recurring here, you can use this recursive selector. So these are plain selectors, then a recursive selector. And to get a bit further, you can also combine plain selectors with the recursive selectors and then proceed with plain selectors. So this specific type of syntax is actually from some of the existing frameworks, but I think the mechanism, I cannot recall the name, but the mechanism is a bit extended to have a bit more flexibility on addressing that. So you can basically, when you receive the response, you can select anything out of the response to then proceed, right? So these get assigned to any value, and then you can define your specific metrics just on the values. All right. So you have a bunch of records that you want to evaluate. You have the metrics defined. More specifics on the specific definition will come later. But then also you need to, or you might want to group the results a bit. And the way Kolibri approaches this is that every kind of request, every evaluation sample provides the opportunity to tag it along the go. There are 3 default tagging stations, but you can really put like a tag, add a tag on the processed element at every point of processing. But one is there initially before processing on the request template, which contains URLs, parameters, body headers, and so on. Then another one after you actually did something with it, right? So you might think like, okay, this looks a bit crappy here, this structure, a tuple of an either throwable or a weekly type map that takes keys, string value keys, and request template. The reasoning here is just that every request will lead to either it will kind of fail and deliver a throwable, or actually result in your metrics being calculated. Then for every key, which is the metric name, you have a value in your weekly type map. This is just called weekly type map because it places key type constraints on the values you can put in. It will not do this strictly, also to speed up the processing a bit. So you will still suffer from type erasure if you do that. Okay, but if you pay attention, then there's no problem. And here it also passes the request template, so you still have access to the first. So what you could actually do here, for example, define, okay, I have requests and I want to filter by the classes of, if I want to make a difference in whether I retrieved only 5 results or I retrieved like 100 results, should make a difference. So I want to place a separate tag so that it's put in a different data sample or aggregation. So all values belonging to a tag will actually be aggregated in the same file. But you also don't need to worry with Kolibri because you can actually define the coarsest level you need. We will see later that, for example, query is one, and then you have all flexibility in aggregating, doing weighted aggregations to reflect the fact that not all queries should have equal weight in an overall aggregation. This might really lead to you not detecting significant changes when you test your search system. And then on the final result, so you have the calculated metrics in a structure that's just called metric row because it contains several data points belonging to different metrics. And here you can, for example, you could apply classifiers belonging to the particular metric value. All right. From this, let's go a bit into what the general mechanics is of the processing, for which we will see an explicit example in a bit. So you have a bunch of data, you have some flow defined, and then I mean, standard procedure, probably also many of you have already had touch points with this. Then it's like combined in a runnable graph. And actually a step before, the framework allows you to split by data. So for example, by query, so that every single query is a single batch, and every single batch will actually be an instance of such a runnable graph, will be executed, result written out in a bucket, then you can go ahead with it. Here a bit more specific, but I also don't want to bore you too much with too much detail, is okay, this is called index generator for quick access of any element or in doubt generation of it. Let's say is resource heavy to keep this in memory all the time. You would just define how to generate the entry, and then this is put in processing messages that are transformed. You have the option of sending it to a separate processor instance, so you can just define the flow itself. For the search evaluation, there's an existing flow, fine. If you write another one, you could just set the option to send it to a separate processing actor, which can just be convenient to encapsulate additional logic, what specifically you want to do with this data point. Let's say you want to do some bookkeeping because you're playing some kind of simulation or something like that, then this can be useful. But then central is the aggregation actor again, does tag-wise aggregation. Tags can represent let's say concepts of different hierarchies. So you can either extend the concept or you can choose to add different tags that are then, let's say, not nested. So they're not representing one and the same concept, but each single one of them. So you have really the choice how to do it. Always take into account a complex tag where just several tags are thrown together would just mean one aggregation, while multiple tags mean, okay, per tag there's an aggregation. Then expectation handling. So after every batch, check that this executed successfully, not too many errors, and then writing per batch results, or actually sending them back to the requesting actor, which we will here usually not do because this comes with a serialization topic. So usually batch executed on whatever node, writes to bucket, everything is good. Then there's just a notification batch finished so that the whole processing can continue. Yeah, just for the high level overview, it's really okay. You shoot from the outside. We will see this goes also via a JSON request. You send a job definition, then there's a supervisor with this coming with certain expectations of what needs to be computed and keeps track of failures and successes and so on. Then separate job managers also keep in aggregations and expectations. Then via router, there's different packages of execution, meaning batches are spread across the worker node. Results are then stored to a bucket, and a notification is coming back that it was successful to proceed. All right, this for that part. Let's go on. All right, so yeah, okay. This section is called RunValue run. So it's just reflected here the fact that the result is reflected by running values, which basically just keep track of the count. You can specify of whether the value should be aggregated, different weights per sample can be defined, and so on. And then just while the experiment executes, these values are just extended instead of like having a huge bookkeeping of all kinds of results and then aggregating it. Okay. One thing that is important is we talked initially about different aspects that could interest you about the search result. So here it's essential that the flexibility and metric definition provided by allowing arbitrary types of the results instead of just, let's say, floating point, reflecting the standard information retrieval metrics, as long as you also define respective aggregation function for two results, and then you're basically good with everything. And the scheme of processing is listed to the bottom. I just gave some central data types just for an overview, but we will also not get too blocked with that. So if you cannot see a code or get bored quickly, close your eyes for 2 minutes and then we're good. Okay, so everything is basically every data sample that's processed is a processing message and can be tagged with types. So tagging types can be either aggregation, which will lead to the separate data persistence, or something like description just for descriptive purposes. It's just that every tag corresponds to a predefined type that you obviously can also extend to other types. And then a context map. If you need in your processing message any other information, you could fill it in there. Then every outcome of such a processing message will actually be a success or fail. And these have different types. The positive one would be corn, and the bad one would be bad corn. So the bad corn comes with a fail type and the certain weight, which by default is just 1. So all samples are equally weighted, and corn is success sample. All right, this is this. The general flow per request is basically this. Okay, we generate a processing message of type request template containing all the information per sample, what is actually needed to send to the server. Then next steps, processing message of, as we already discussed, an ether of throwable and weekly type map containing, in the case, for those who don't know, an ether is either the one value or the other. So it's either a throwable or it's a weekly type map containing all the values from which you can compute metrics. And together with this, sending the request template. Then based on the sequence of calculations that work, it's basically functions on the weekly type map that provide you an output value. This is further processed towards processing message of type metric row, which again is just a combination of different kind of metric values for the same parameter setting. So, okay. Out of this sequence of calculations, you get a sequence of metric values, and those metric values are then per tag put in different metric documents, which is basically, you couldn't imagine it like a standard CSV file. For example, you have one row and then you have many of those rows. And this is basically what it is. Then in the end, you have writers for either CSV if your business asks, and or JSON in other cases. For our front-end purposes that we will see, JSON is a bit more convenient because you can define the time series and so on a bit better extractable. Okay, so this is actually, so last few code snippets for now. Hold on, please. And in case that happened, wake up, Charlie. But I'm sure he also didn't fall asleep. So.
No, I'm awake. I'm awake. Don't worry.
Okay, good. Okay, so as said, like for a specific metric, you will find the metric value. This has a name, the name of the metric, and then the what is called here a by-running value, because what we want, why I'm mentioning this is we want transparency about everything that's happening in our calculations, right? So you could have a super nice value of, let's say you have a super nice NDCG, but then at some point you discover, just one sample out of 100 was evaluated and this happened to be good. You have a problem, right? So we really want to keep two records. One is keeping the counts of the failures and every failure type on the way. So you know, did the request fail? Did I just not have results for the query or anything else? So that this is very transparent from start to end. And you have actually all the samples that did go into successful calculation. You also have the stats on that. So how many were this? How many? And then really have both sides of the world. Then any single running value, so here in the B running value, replace the aggregate value with actually a running value here. And this is just, again, no need to know the details, but it's just to say not all corn is equal, right? Not every sample needs to be aggregated with the same weight. This is why you have like a weight here, a number of samples that go into the value itself. Then this just defines how you would treat if the value is weighted again by some other value, right? So let's say you start your experiment initially weighting everything the same because you know you have single query results anyway. And then you go, yeah, but now I want to aggregate them applying the weights that I stored in some other mapping. So then it's basically just on the running values here called the weighting function, which in the default will just multiply the weights. So you might have 1.0, then you say, yeah, but it should just have the weight 0.5, then both are multiplied and that's it. And then some add function that defines how two separate values are combined. And then some supplier of some initial value and an aggregation type. So aggregation type could be like, okay, average double or an unweighted histogram, things like that. Okay, yeah, now as announced, time to open your eyes. And whoever saw 1899, wake up. But it's probably a special, just for a few folks. How to use your own metrics. So basically, again, definition of request for which we will provide data types. We will see samples to simplify this. Then you need to specify, okay, what is actually the data I want to get out of it, assign a name to all of these. Then after you assign this identifier, for example, product IDs could be a sequence of product strings in the type map on which case the calculations are defined. So you will find all these things you pick from the request in this map. So you can just say, I want this key. I define my calculation on top of that. Whatever I do with it is good. And then as said, the identifier is used in the metrics, which is then basically just a function on this type map to any value. And here in this type map, you have access to any parsed fields. Just the types that you use in your function then should match. And this is then processed to, again, this is just the very same concept. It's just the name of the metrics and whether it was successful or not. And then it gets aggregated in those running values. And that's basically what's happening there, right? All right, we managed to do that part. Sweet, the practical part is coming closer and closer, and I will try to keep it short because I see that we already progressed a bit time-wise. Okay, so next question is, why should I adjust the front end if my backend offerings change, right? This is always probably all backend developers here can relate. This is a pain point. You need to synchronize or change something, right? And this is where struct devs come to the rescue. So just a small sample down there, but as you see, Hulk is also annoyed and wants to smash the code and given him a demo. So we'll do a demo in a short moment. So this is just what's called the nested field definition. If you have experience with Spark and so on, you will see the very same. So you have some structural definition in which there's fields defined. Every field has kind of a restriction on what names it can take. Here's just a constant. So for example, name. Then it has a restriction on the value it can take. For example, the regex struct def here just means, okay, I check for this regular expression, which means I allow everything in this case. And then you can just define all kinds of regular expressions to define to the front end what you actually expect, right? And all right, let's see this in a quick demo. Actually, the demo is just a local mock setup, right? So I'm not pulling off like some Elastic or whatever. There's something that's called response juggler that I just, it's just a Python project that allows you to define general templates for responses. So you can locally very conveniently check whether your parsing or your selectors are actually doing the right thing, right? Because you can just shoot it against this response juggler and see whether you get useful metrics out of it. And Kolibri itself and the Kolibri UI, which is called Kolibri Watch. All right, then let's have a quick look. Don't worry, the code is just there. We're not going in depth here. Just starting up an instance. You will see here that when you look at the project, so you see the cluster forming here, and at some point it will tell you, cluster is up. You'll see in the Docker Compose, you will also find the Prometheus, Grafana, so there's a dashboard actually attached to it. But here you will find the setting for actually Kolibri base, picking up the newest release. That's what the backend is. And then you have basically two instances here at this very moment. So you have, this is of type compute. So we just, no, sorry, this is roles HTTP server. So it's just accepting requests. Usually you have one HTTP server and then for this is the second instance, and here we use the compute. So only one of them will actually do the heavy lifting. Not going to go in detail over all the mechanisms here, but you see, for example, discovery method is config. So there's just a config stating, okay, pick those two instances. In this sense, it just refers to the identifiers Kolibri 1 and Kolibri 2 in the config used for that. But again, there's node discovery for AWS. You will find examples above for Helm charts, for Kubernetes and the like. All right, what we also pull off is the response juggler just to send some requests. So if you see P1, P2, just like some fake product identifiers, that's the reason for it. Another instance of response juggler, and here Kolibri Watch, which is very small. So you just give a Kolibri base URL, where do I am able to reach the backend, and that's basically it. So then we can actually have a look at the setup. And it should actually be here. Yeah. So this is actually reflecting to you, okay, what is actually my cluster doing right now, right? So if I had like 10 nodes here, I would see 10 nodes reflected. If I start a job, I see running jobs, and I see also the batch status. So the single batches, how far they are in execution. So here actually comes what I mentioned with like the expectation from the backend being communicated to the front end. This is actually here, for example, if we take a full search evaluation, we get like this whole range of things to fill in. Obviously, this might be a bit annoying initially, but here we have kind of explanations for what which field means. But let's say you have a template for it. So first quick thing, is actually you have validators on these fields, right? So for example, if I don't have anything in there, invalid values will actually give you something, but I do not need to adjust my front end just because I'm sending from the back end another job definition here. All the fields will be built automatically. If I have an existing definition, I can just say, all right, I have them in a folder, so I can actually relate to them. Give me one, and it will just fill those to the values. And here we'll see, I have a I have a value mismatch. I can actually not select response juggler here. So the template is wrong. It will fill all other fields where it can and just give me warnings where it's not valid anymore. And then I can quickly adjust. And here below, save it again. So this definition, if you really take the full job definition with all configuration possibilities, this gets a bit long, but here you can say save template or run template. We will run a bit of a shorter version of the whole thing. And so let's jump to job definition short. And then we take the reduced one here. We change this to test job 5. And you see here that to the right, while you fill out stuff, the right JSON builds itself. So you get full transparency. So So this was not selected there. Let's see. All right, yeah, this should be fine. So you get showed full transparency to the right what you could just post against this endpoint here, right? So this endpoint search eval query reduced. So you take the base URL of your backend and you just shoot this request here against and it will do the evaluation. Okay, now we can actually execute this. One thing. Let's quickly select this again. Just want to avoid that there's any residue. Yeah, okay, this is a bit shorter. Okay, I just freshly loaded one of the templates into it. And so when I say, okay, run template, I know that this already exists. So I select another one. And then I say, okay, run the template. It will give me a quick okay. Then I will see here, it's already writing very quickly the results because I'm not executing so many queries here. And so in this test results subfolder, I will very quickly have the singular results, right? So you see here that, for example, Apple, I think this needs a refresh. Yeah, so you see all these queries here, once in the writer for JSON format and once in CSV format for every single query here, like Pepsi, milk, meat, and the like. And here an overall aggregation also in CSV format. This CSV format is a bit adjusted because you need to add the actual types of the single values here, right? So for example, this is a combination of just the information retrieval metrics and to the right histograms of occurrences. So just to keep it very transparent, what means. So we have here, for example, the search endpoint. This is what the response juggler does, just giving us any combination of this. What the selectors do that we see in a moment is just picking all the sequence here of these IDs under string value 1 and then calculating the histogram of where in which position those did occur. So this is basically specified here in the script. So we have here the selector for the string sequence, and then we have a metric that picks this up. So this is what I meant with, okay, we extract it and then we reference it here. It does this over the first 10 position and stores this in the as string histogram result or metric name. And then we can actually, after we executed this, obviously we'll find this in the job history here. It's being executed. We can also go and analyze. And so we can, this actually loads the state always initially. So we need, okay, test job 5. Then we look at the overall results and we can, for example, here check, just remember the results were generated randomly. So if you see patterns there, we can just display it this way. We can always, when we scroll over it, get the labels for it. We can also deactivate the display in case we have multiple. The way multiple, so for example, for comparisons work at the moment, you just create both and then you say, merge them. And okay, then you can actually just compare both metrics there. And for example, for the histogram metrics, this is a bit, we just need to select one of the parameter settings for which we need to evaluate this, because obviously displaying all the histograms at once will not be good. So here we just had one parameter that we modified and changed the value. And so then we need to see what the value, which value here is of interest to us. So for example, P0. In practice, this could just be a category, right? So I am interested in category fresh, for example, for query Apple. And then I could say here, okay, add the data, and then I will get a histogram here, right? Okay, it's nice. Then I can check that. I can check another one. And then I have 2, and same here, if they are of same type, I can merge them. What will automatically be done is that the scales adjust. So if someone had no entry here at position 4, this will also be reflected here that there's no entry. So I merge them, and then I actually get a combined display, right? So yeah, this is a quick overview of kind of what the front end provides you. And with this, I would jump quickly back here. So this was demo time. And basically, as we discussed, cluster state, job definitions and execution, result visualization. But obviously that's extendable, right? So that's the first throw basically at visualizing results, what's kind of missing at the moment, tabular format like resorting and additional things, which I actually, and then you actually released, or questions after, is the Outlook. So obviously there's nice extensions that can be done on top of it. One is adding metadata for experiment runs so that instead of keeping templates somewhere, you just know, okay, on September the 2nd, I executed this experiment, let's just redo it. Then extending visualization. So for example, matrix distribution per single parameter value. So what is nice there is, for example, violin plots, which basically give you a better form like of box plot on histogram, like combining this information to give you an overview, to just see like, okay, how much does a variable probably influence kind of the variance in the actual metric that is of interest to me. Then a snapshot of results for a selected number of queries and defined parameter settings, just to have a gallery over my experiment transition to see, okay, on the 2nd I executed this, looked like that, we made this change, then looked like that. Then something like an evaluation card. You saw that, okay, we can build something like this let me see. We can build something like this, but we might want to standardize this, right? So that every time automatically this is just generated. This might be helpful. So what did we look at in experiment 10? Then parameter setting timeline and score overview plus visualization of changes to the status quo. So whatever I had at the very moment, what did the change actually do, and to create transparency on top of that. Then a task queue and scheduling, so that you can just dump as many experiments as you want on it, and they just get scheduled one by one. And then for visualization in e-commerce, always kind of helpful event overlay, right? So when did we see marketing events, holidays, and the like? So now good news, the end is near, and let's agree I talk too much. And now I'd love to hear about you and what you'd like to be in actually the functionality. And finally, before you go, if you like the project, the idea, feel very invited to start the project on GitHub. All right, thank you for listening.
Thank you, Andreas, and also trying a live demo on a meetup, even a online meetup is a brave thing to do. So applause for that. So do we have any questions for Andreas? Please have a think about that. Drop them into the Zoom chat window, and I'm sure he'll do his best to answer them. So we've got no questions so far. Anyway, I'm going to ask a kind of meta question here. Stavros, who was here earlier, I think I'm afraid he's gone. He asked a bit about what the goals of the project were. We've seen a lot of implementation detail, but no overview of kind of why you did this. So maybe you could just tell us a little more about that while people prepare their questions.
Yeah, that's a very good question. Like, I hope to be able to answer this in this talk, so I'm hopeful I can do now. So the initial idea was really having something general, right? But obviously that's confusing, like, to everyone kind of who wants to use it. So the very specific use case is offline evaluation in the search space, and then extendable. But that's kind of how people can understand it, providing all kinds of simplifications. And so, for example, when you look at the front-end edition, adding more explainability, but this also will get more intuitive to use, I guess. Yeah, really also creating this kind of storytelling on top of that, right? So the outlook that I shared, actually making more transparent how your search result more by applying changes and kind of understanding a bit more like about changes in your search result apart from the purely numerical, which is also included because they're important numbers, but really providing some convenience there.
Okay, that's great. Thank you. Hopefully that will answer the question for Stavros, who will maybe look at the video later. So do we have any other questions from the crowd? We've got a small crowd, so if you've got a question, I think you can probably just unmute yourself and pop your video open and ask us directly. Who's got a question for Andreas? Don't be shy. I think you fill their heads so full of information, they are stunned into silence. Or maybe they're frantically downloading the code at this very minute and installing it,
I
and
guess.
solved all their problems. Go on, who's got a question for Andreas?
Hi, Andreas. My name's Laura
Hi.
Pavlov. I'm a UX designer, and I'm interested in thank you for this awesome presentation, by the way. Interested in looking a little bit more at the dashboard. Could you share that again and maybe like talk through it a little bit?
Sure. Is there any specific aspect that you would be interested in?
No, maybe just an overview.
Sweet. Let me quickly reshare. All right. So the overview is really like, so here you got initially the status screen. So what actually makes your cluster, you pull off another node and disjoins your cluster. You just have an overview of this, right? So for example, let me quickly start another run of the of an experiment. So let's say I select a full one, a big one, and then I go like execute this. All right, then running the template, and then like if I jump back, since this is running for quite a while, it will actually here show you kind of what the batch is. It's actually running, and shortly there will also be a status update here on where's your batch at, right? Is it processing? How many messages you see this there? What's the total number of elements? How many are actually processed, right? And you also have the option actually to kill the whole process. Creation is just really a thing to provide like, okay, what's the job definition? What can I shoot back at the server and already provide me all information that I need to render here these formulas, right? So that I actually don't need a front-end adjustment in case I want to change anything. With validations and so on, so that you have some convenience there and some explanations here to the left. You can actually at every level include explanations, but that's something that's defined at the back end. Here I didn't do it for the nested one, so it's just on the outside, but you can do and explain more to the users. History is just giving you what did I already execute. So here, overview, then and then I executed it. And analyze is really a means of, okay, here that's my experiment. I ran the experiment test job 5. Here I want to select the aggregation of all. Or I can also look at the single results that I have in my folder. But what I did not show initially is that there's a wrap-up function defined here. And you have many different wrap-up functions. So after everything is executed, what do I want to do then to wrap up my job? And here it's an aggregate from directory by a regular expression. So here I just take regular expression. What is the output file name? How is it to be named? And what's the subfolder I want to do this in? And here you can additionally provide either a constant weight. Here all are treated equally, or a different weight. So you can configure all those things, and then the last step is just like, okay, I want to analyze it, look at the data, look how it looks, how data is distributed, and the like. Does this answer a bit?
Yes, thank you.
You're welcome.
Great. Do we have another question for Andreas?
Hey, Andy.
Oh.
Hello. A question here is this. To be honest, we have talked about this because I'm a colleague of you, and so the question will be about potential end users of different technical levels. How can we do to adjust to everyone's needs?
That's actually a good question. Thank you. Yeah, so this is actually when you look, I'm not sharing anymore, right? Let me quickly share back because here you actually see, okay, what does a full job definition look like? And I fully agree, right? You do not want to configure all those options. If you do not have a template for this, you definitely don't want to like fill all those fields, right? So that might be a bit disturbing. You can, though, define those job definitions on all kinds of granularity. Let's say you have an agreement, you always calculate certain set of metrics on always the same file name, on always, and so on. You can condense this. And this is what, for example, is reflected here in search evaluation short. If you select this one, the number of fields, right now it's pre-filled still. So this is a, but let's see the short evaluation, you see it's already way less fields, right? Because some things are pre-filled. So the goal is really, if you have someone that's not tech savvy at all and does not really know what to do, you could condense this to a single field or no field at all if you pre-configure everything in the backend already. But this is a part of specifying the job definitions in a way that are convenient for different sets of users. You could customize it the way that every job definition is just for the layman, just pressing start, basically.
Great. Do we have any more questions for Andreas? Well, in that case, I think we'll wrap it up there. Thank you for your early Christmas present of Kolibri, and I hope everyone enjoyed the talk. So we've got a few announcements for the end here, if I can just share the appropriate screen. So we always need more speakers for Haystack Live. So if you would like to present on one of these meetups, then please go to the Haystack website. There is a submission link there, or contact me directly. We have a talk coming up in January, on the 12th of January, of Genia from Toloka on data labeling for search relevance evaluation, which I hope you all come to. You can sign up for that now, and I see lots of people already have. Do check out the Search Meetups map. I've put a slightly updated link there because I'm not sure searchmeetups.com is working. Maybe it's just my DNS playing up. It's always DNS, as they say. It's always DNS. And if you're not on Relevant Slack, where have you been? So join Relevant Slack. There's over 3,000 people on there now. We've had another couple of hundred join in the last month. I think there's somebody put a call out for any open positions at the moment, because there are some companies laying people off, and it'd be great to get to help our search relevance colleagues find work. So do jump in there, and there's a jobs channel. And all the talks from Haystack Live and many other events are on our YouTube channel. We've got over 100 videos there, so it's a great resource. Do feel free to publicize that. So that's the last talk from Haystack Live for 2022. And thank you again, Andreas, for a fascinating talk. The video will be up online as soon as we can make it so. And we look forward to to 2023 and more exciting things happening in the world of search. I'm actually working on the dates for Haystack US at this very minute, so hopefully we'll see some of you there. But there'll be many more things happening. So thank you all for coming, and we will see you all again in the new year. I'm Charlie Hull. I'm from Open Source Connections. We're the Search and Relevance people. Thank you. Good night.